Hi, everyone. Good evening. Welcome to Machine Learning Engineering Track Breakout Room section. Hope you're all doing well. So let's give some time for those who are joining in. So in about 5 minutes, we are going to start today's section. Okay. Good evening, everyone on the call. Please, if you can hear my voice, let me know. Can you all hear my voice? Okay. All right. So, welcome to today's break room session. Um, Today is going to be an interactive, and we are going to enjoy ourselves. So, I'm going to share my screen now, and then we start today's section. Okay. Please, can we all see the screen? Can we all see? All right. So today we are going to take a look at a machine learning real world business tax. How do the world use machine learning? How do they show the insight? What kind of questions do they ask? How they go about the whole, their whole work. When to use the metrics, the specific metrics to use. We are going to find out all here. All right, so without wasting much time, let's start right away. So on my screen here is a real world business tax. And here is a simple context. A school, let's say an institution, wants to uh, understand a situation going on in their institution. So the schools and then the policymakers want to raise exam pass rates and then reduce dropouts. So it looks like they've seen some discrepancies going on, and then they would like to see if there is a way they can raise the exam pass rates, and then also make sure that a lot of students stay in the school and not like the students who are struggling drop out of the school. And the teachers often don't know which students are struggling until after midterm or final exam. We've all realized this, that in our schools and in both a lot of institutions, education institutions, we are only able to assess student performance with the midterm exams or the final exams. But uh, this school wants to avoid situations like that. They would like to know the changes and then the outcomes before it is too late. They can't wait for they can't wait to the end of the semester before they assess to know how students are performing, right? Yes. And then when it comes to resources, how do they factor resources as well? Resources for tutoring and then academic supports, which are also limited and not always targeted effectively. So since we don't want to wait till the end of the semester to know how students are performing, how do we assess the performance of the students who are struggling? And how do we distribute resources to help them? So these are a real world context from a policy, from schools and policy makers, you know. So how do we, you know, with the limited resources we have, how do we distribute them equally so that all the students who are struggling academically will be one way or the other be supported? All right, good. And then as a result, because of all these are not taken into consideration, it is too late for these institutions to intervene. Right? Good. So now this is a real world uh, business challenge. And then the challenge here is that we want to improve students' outcome. We want to improve students' outcome. So today, as you are on the call, you are a machine learning engineer, and then uh, an organization and let's say an educational institution reach out to you, and then the first thing they say is, we want to improve student outcome, you know, because you can't just start picking data sets from anywhere and then now you start trying to fit a model. What is the context behind the model? What challenge are you trying to solve? So today, we are not thinking as model builders, we are thinking as problem solvers, people who want to solve real world problems with machine learning and not just building model, because if you don't understand the context, the challenge of what you are trying to do, then the model you are building has no effects on the context or the situation at hand. All right. So in most cases, I brought this challenge because I was given a task when I was interning with a company. And then most of the time, if you have never been to a robot set, you feel like someone will just drop a data somewhere for you, and then the first thing is you start, building your project. You start importing pandas, and you start using your Seaborn and then the math quality to do your visualization. And now you call on regression and linear regression. And now you call on your model metrics, and now you fit your model, and then wow, this is what I got. Oh, my model is performing well. Well, my model is not performing. Let me fine tune using cross validation. Wow. Oh, cross validation is also working. Okay, now what do I do? Let me bring in model fine tuning. Wow. But the real case is you will not be given a data set. The first thing you'll be given is a business task. And then before you tackle, you have to understand what the context, the business is, whatever industry you find yourself. You have to understand what the challenge is and the specific problem you are trying to solve. Here, we are trying to understand the students. You are trying to improve student outcome. It is different from, say, modeling students studying hours. It is different from, say, finding out if students are going to drop out of school or they are not going to drop out. So even in specific institutions and industries, You have to understand the context from what the industry, uh, what stakeholders want, what the policymakers want, what are they trying to achieve. So you have to understand it in that regard. Then you now move on to you as a machine learning engineer. What do you have to do? So I made something here. I said, we are going towards a business question. So we know we are trying to solve students' performance challenge. But what is the key business question that needs to be solved? What is the key business question that needs an answer? So I brought out something simple for us to see. You can see business question. How can we predict students' exams performance early enough to intervene effectively and improve outcome? So here, what I'm doing is, the question I ask myself is, how can I predict student exams performance? Let's say a senior high school, or let's say a senior secondary school, how we all understand it, has come to me that this is the challenge in their school. They've realized that they are only able to assess the performance of
Hello,
students.
sir. Sorry, we
Yeah,
cannot see your screen move.
okay. Please, if you cannot see the screen, let me know. Let me see your hands. Oh, okay. All right. So hold on for me. Please, is it okay? Can you all see my screen?
Not yet, sir.
All right. Okay, hold on for me. Okay, how about now?
Just your picture that is showing, nothing else, sir.
Oh, wow.
It shows you're presenting, but I don't know if you're sharing your entire screen.
Yes, I'm showing my entire screen here.
It's
So I don't know why.
still not showing, sir.
How about now? Do you see? I'm presenting a Word document. So do you see any Word documents?
No, sir.
Well, what is happening? Okay, all right. So
You can reshare your screen again. Stop the presentation, then share again because it shows you're presenting, but it's just blank, like nothing shows.
all right. Okay, let's do this again. Okay, how about now? Do you see my screen now?
Maybe it's my network still the same thing, but let me
No,
rejoin
sir.
the call.
No.
Nothing,
I
no,
can't see.
nothing.
I can't see your screen. It's showing that you are presenting, but we can't see the screen.
Oh,
Okay, so
So
it's the
maybe
same
you
thing.
can just log out and log in again. Maybe it's
all
network.
right. Okay. Now, oh, Okay, so how about now? Do you see my screen?
Yes, sir.
Okay, please, if you cannot see my screen, let me know. Do you all see my screen now? All right, thank you very much. So, since let me start from the context. So this is what I was talking about. The situation, the context, the challenge, which is at stake. And then what we want to do is that we want to improve student outcomes. Why do you want to improve student outcome? Policymakers have raised an alarm, and then they want to know why uh, students are dropping out of their schools. And then could it be that the exams pass rate is too high or it is too low? Teachers also often don't know which students are struggling until after the midterm or final exams. So what they want to do is that they want to find a way to understand, to be able to assess students' performance before they even write their end of semester exams and also their final exams, so that they'll be able to distribute resources, the limited resources available to the students who need support. Yes. So this is a business question. So the business question here is, how can we predict student exams performance early enough to intervene effectively and improve student outcome? We don't want to use final exams to assess the performance of students. We want to know how these students are going to perform in their final exams, so that we be able to distribute the resources we have, because definitely the institution have limited resources. So you want to be able to assess that at the end of the semester, this student might get a pass mark of 50 or 60. So how do we help the students with the resources we have? Could it be that the student is struggling with a particular subject, or the student, does not sleep, so because of that, they find it difficult, this number of sleeping hours? Could it be that maybe the extracurricular activities the students involve themselves in could be a factor? So they want to, combine all the factors that they think, can influence a student's performance, and assess it early, very early, so that they will know, okay, at the end of the semester, this student is going to score this marks. So let's help the student out. They're not just, guessing, looking at the student and guessing. If I look at you, you'll not perform well. You know how when we were in schools, and then most of our teachers used to do, they can just look at, especially if you are sitting at the back there, they know you are useless and you don't have a future. So they can just look at you and then, hey, those are the back. You are kind of like you are in the school, you are in the class, but you're not part of the class. So most of the time, their concentration is those in the front, because they are the serious students, and they are the ones that need the attention. But in most cases, it is not supposed to be so. That is why you are a machine learning engineer. What are you supposed to do? What's insight you want to draw from the business question, right? So in here, this is what I wrote. Since I want to identify student performance, why? Why do I want to do it? A lot of students may be at risk before it is too late. And it could be that is why institutions are there. They are not there to only support students who are performing well. They are there to support every student and their challenge, every student, and the support they need equally, so that we will be able to enable tutoring and academic support. There are some students that need so much time with particular topics. For most of us, that is elective mathematics, calculus, and then a bit of differentiation, in senior high school, because it was in the early days, it was struggling for some of us. So if you find yourself in a case like this, you don't need to be able to, go through the school without any support, academic support or tutoring support. That is why the institution wants to know how they can distribute their limited resources they have. So as a machine learning engineer, you are going to show them that this is how you should distribute the resources you have. These are the kind of students you're supposed to target. This is a group of students that you are supposed to target, right? So that is why we are here. And then before we proceed to the next thing, I want to ask, if we are presented a business question like this, how would you know if this is a classification problem or this is a regression problem? So anyone? Please, is my voice being clear? Is my voice clear? Give me thumbs up if you can hear my voice clearly. All right. So, okay. So we are on the course. So I'm framing the question again. We want to predict students' exam performance early enough to intervene effectively and improve student outcomes. How would you know if this problem is a regression problem or a classification problem? So this is a question to you, or who is going to answer the question for me? Please answer the question for me. Okay. All right. Let's hear you.
So isn't it by knowing your target?
Not necessarily. Looking at the business question you see on your screen, how do you know if this is a classification problem or this a regression problem? How can you tell from the question? Because it is the business question that is going to tell you how you're going to tackle the issue head on. Yes, Yaya?
Good evening, sir.
Good evening.
So if your target variable is a yes or no answer, or 1 or 0, you know it's classification. So based on the fact that it's either yes or no, you know that it is a classification, whether passed or not, or maybe will purchase or not, you know that's a classification. Then for regression, it's a continuous value, let's say predicting the price of a house. So that numerical value is continuous, because number is continuous.
That is great. That is great. So here, looking at this question, we want to predict the student's exam, which makes our question a regression problem. All right. So everyone, let's give it up. She has really done well. Let's give her a thumbs up. She has really done well. She has really done well. She has really done well. Yes. So the business question we have here, this is a regression problem. We are not predicting whether a student is going to drop out or not. We are rather predicting what the student exams performance. How are they going to do? Are they going to score a good mark? What marks are they going to score? If we give the student a range of 70, a range of 50 to 80, what score do you think we're going to get from the student? That is what we are looking at here. So since this is a regression problem, the next thing we are going to do is what? Check our approach. How are we going to approach this question. So I wrote a simple approach here. So this is our approach. So how do we tackle the problem? We are going to need what? A data, a clean data. We all know machine learning cannot perform well on a data that is not good, that is poor, that is bad, lack a bit of consistency. Okay, so we are going to first collect data, and then this is the data that we are going to look out to, the study hours. How many hours that a student, sit behind the books. Some students can go as far as studying about 4 or 5 hours a day. Some students can do 6 hours a day. We are going to factor all that into assessing the performance of our students. We also take into the sleep pattern of students. How many hours does these students sleep? We all know that scientists have time and time proven that having a quality sleep also have an effect on your performance as an individual. So average, if you can have about 6 hours sleep over the night, you are going to look energetic the next day and prepared for your day and then whatever tasks ahead of you that day. You are going to look at test prep. How many test preps is available onto the student? How are these test preps? How effective are they? We can all look into that. Most of the time, when you are preparing for your final exams, tutors make available past questions. These past questions enable you to know how to prepare, what you are supposed to expect. It will not be as though you are going to expect the same question, but it can help you to, tailor your learning. What to study, what not to study, what we are going to expect exactly, and then attendance. We all know that if in a semester a student is supposed to attend class 53 days and a student attend less than half of that, we all know how one way or the other it is going to affect the student performance. Yeah, but we are not going to only look at only one aspect of what the factor. We are going to consider a lot of factors together, and then students' participation in the classroom. How do students participate in this? So when teachers are aware of all this, they'll be able to engineer their tutoring and also the resources they have. You are a teacher, and then you realize that there's a particular student who has never in his or her entire life asked or answered a question before. And some you realize that maybe that student is not because he or she is lacking the knowledge or lacking understanding, but it could be an issue of self-esteem. The student lacks confidence. How do you help a student like that? By always, all the time, asking the student question to build up what the student's confidence. So we can all consider all this into our problem and then find a way to go about. Then the next thing is also explore the data, find trends, and then the drivers of performance. You can use visualization. You can use box plots. Box plots can help us, understand outliers. We can use scatter plot to assess the relationship between the number of study hours and also the attendance. We can use it to also know the past records of the students, the study hours, and also the exam score. We can use scatter plot to assess the relationship between all that, and then we go ahead to build our linear regression as a baseline model. You want to know how how these factors are linear. If these factors we are taken into consideration are not linear, then we can consider polynomial regression, where it captured the nonlinear relationship among all these factors, and we can also look at multiple regression as well to capture this in a real-world scenario. Then from there, we move on to evaluating our model. Evaluating our model. How do we evaluate our model? We want to know our R square. R square is our R square explains the variation in the exam score. We are predicting the exam score. The R square is going to explain the variation in exam score. So if we are getting 85% of our R square, we know that the model explains that the difference in the 85% of the exam score of each student. We can look out to our errors and then the mistakes in our regression in our model. We know if a model has a mean absolute error of 0, that means that the model does not make any mistake at all. Although in real world cases it is not, so it's not possible. But I mean, assuming that we know this is what we had with our mean absolute error, we know that our model do not make a mistake when predicting. All right. We can also look at our mean square error, and then the mean square error also explains the squared error. So if you have a squared error of 0, we know that yes, our model is doing very well. Although that is not achievable, that is not possible in a real world scenario. Then we now draw insight. So looking at what you have after building the model, the next thing is to draw insight. So you are going to answer this question. You are going to say, after I modeled the data, I have learned from the data that student hours and test prep are the strongest predictor of exam performance. Meaning that if a student studies for a lot of hours and also take into consideration their test prep, that means that student is going to perform very well. If a student does not study for a good number of hours, if the student study for low hours, 1 hour a day, and pay less attention or little to no attention to their test prep, we know that such student is not going to do well in the exams. All right. We can also take into consideration the attendance and participation. Although here we can say that attendance and participation also matter, but they have a smaller impact. That's students coming to class all the time and then the students, participating. So we are saying that even if a student does not really attend class and they still study very well and still prepare with their test prep, they have a higher chance of scoring good exam score in their final exams. And then there is also here sleep has a sweet spot, but too little or too much low performance. That means that it doesn't matter the number of times a student is going to sleep. As long as the student is studying very well and preparing with their test prep, then they are good to go with their final exams. All right. Then we can talk about the difference between the polynomial regression and the linear regression. We can say polynomial regression captured the nonlinear effect between the nonlinear effect better than all linear model. We all know that the regression, polynomial regression does not follow the straight line like a linear model does. So it is able to capture the nonlinear effects of our data, and we can go into our variation score, and then say, okay, 75 to 80% of our variation score indicates what a strong enough for early intervention. That is that now we can tell that looking at our model variation, if we put these measures into consideration, if we're able to assess this, study hours of students and their test prep, then we don't have to wait for the student to write their final exams and know their performance. We can now start helping them right now. So what do? Tutors, we deploy tutors into their class. Find out from the students the number of hours that they are, putting into their studies and also their test prep. So for those who are lazy and they find it difficult to, study for long hours, how do we help them? Students who don't have access to test preps, how do we help them? So these are the way we can help to improve the student performance. All right. So when you're able to do this, yes, you can now tell yourself that you are a machine learning engineer. You are able to draw insights from data and be able to provide an answers to a business question. All right. Then from there, we go on to recommendation. So how do you do it? How do you recommend this insight into action? How do you, tell policymakers, the stakeholders, and then the tutors? Deploy predictive model in a pilot program. So let's say we consider 1 to 2 schools, and then we check how this model is going to perform. All right. Then we build a dashboard for the teachers to flag at-risk students early. So we have a dashboard and you can tell that, okay, looking at this student, the number of hours this student learns, and looking at the test preps that are available to this student, I have to start helping this particular student before he or she writes his final exams. And then also be able to provide, targeted tutoring. That's for these black students instead of just spreading the resources across. So now we'll be able to, distribute the limited resources the institution have to these particular students that have been flagged. Then what do? We expand to more schools after the successful pilots and tracking outcome. So if we are able to come up with this, if you're able to engineer this, then you can tell you are confident that yes, I can draw insight from data as far as I understand what policymakers and then stakeholders want to achieve, what problem they want to solve, what challenges at hand. And the business question I will have, at my disposal. I'll be able to draw insight, from the data and also give recommendation as to how stakeholders and then policymakers and then teachers can tackle the problem at hand. So when you are done with this, then you are sure that you have a fair understanding of how a real world machine learning business task looks like. All right, so that is that. Thank you very much. At this point, I'm opening the forum for questions. If you have any questions, you can ask the questions. All right. Okay. All right. Thank you very much. I really appreciate that. Thank you. So, any question? Yes. Okay. All right. I think someone raised up her hand. Please go ahead and speak. I think the person has left the call. Okay, Godwin. Please, Godwin, go ahead and yes, Mr. Godwin, go ahead, followed by Samiat. Mr. Godwin. Okay, I think Mr. Godwin is not speaking. Samiat, go ahead and speak.
Yeah, good evening, sir.
Good evening.
Yes, so please, I don't really understand because I was focused on something. So I want to ask this question because it has been on my mind regarding this topic we're talking about today, which is that in situations whereby we don't have data, for example, in Nigeria now, like whenever I want to work on some projects and all of that, what I find is challenging is getting data. Like not all data are not available, but in Nigeria, I just realized that we don't store data, like we don't have database. But my main question is, like in a scenario whereby I'm given a task, like to work on something, and I'm unable to get like data, like and I can't use this other method where I just use. Like how do I go around the data? Like to be able to know that oh, this data is even not, or even if it is not all of them that is accurate, at least to some extent. Like I know of going to Kaggle and this other one, and some other websites. Well, how do I get data?
Okay, that's a good question. So this is what you do. Um, in real world cases, data is not always available for you. So what normally you do is that um, you try to find out from other sources any data that is similar to your tax. Okay, any data that is similar to your tax. If for some reason the industry is a bit challenging and there's no data available, there is a way you can use Python to generate synthetic data. Okay, yeah, there's a way you can use Python to generate a synthetic data, which I'm going to, I mean, we go about this some other time. So you can use Python to generate a synthetic data, and then you can have a data for yourself. You can make it such that it will not be a perfect data. You can make it such that you have to clean it yourself so that you'll be able to, assess your data manipulation skills. You can make it such that it doesn't have to be very perfect. So we can use Python to do that. And most of the time, that is what I do. I don't go to Kaggle and I don't go to I'm sorry to get data because most cases those data look so perfect. But when you are given a tax from a company, from an institution, and then they have a data, that data is quite messy, very messy, very messy. So for me, I entreat people that I get in contact with who are into data science and machine learning to not rely on data from these sources. They are too perfect for you. Right? When you generate synthetic data for yourself, it helps. And you don't need how to, what you can do also do that there is we can just build a pipeline. After building a pipeline with your synthetic data, all you have to do is just, call all the data you have, then it will be able to generate the prediction for you. So even if you have a data available, you just build up an end-to-end machine learning pipeline. Then now you now fix your data into the pipeline and it will generate what the prediction for you. So in your case, try out how to use Python to generate synthetic data, and then I believe that that will be a good start from there. All right.
Okay, like this is a new one for me. Thank you very much, sir. I will look into this. But as we go on with our courses, is there any future we're going to learn about this, like how to do this more? Because I'm still interested in how to get data.
All right. So that reminds me, I'm going to. I think most of us will be interested in how to generate synthetic data with Python. So in the course from next week, Monday, I'm going to guide you through our Discord channel how to create a synthetic data with Python. So that's for those of us who are interested in learning how to generate synthetic data, then we'll be able to follow that. So we will do that. Okay.
Okay, thank you very much, sir.
You are welcome. You are welcome. All right. So, Mr. Godwin, let's hear from you.
Okay. Hi, can you hear me now? No?
Yes, I can hear you.
Okay. Sorry for the other time. My question is similar with the one the first speaker just asked. So I will build on it. My also second concern is, so if you are using Python to generate synthetic data, won't there be bias as regards the data that comes from us, from Nigeria, for example? Because I'm just feeling that first, my first fear was that, okay, even if we are getting data, won't it be too small for maybe a particular school, for example? Won't it be too small to, test it well? Then secondly, okay, you brought the idea of using Python to generate synthetic data, and I know that the data out there majorly doesn't really fit into us. So when Python generate data, will there be bias, or will it remove biases as regards our own real situation, for example, in Nigeria?
Okay. Thank you very much. So, there is a way you can make the data have a real world noises. Like, inconsistencies with data labeling, missing data, the null values that are missing. You can use Python to generate that. So that it will sound like a raw world data, because in most cases that is how real world data looks like. They have noises in them, they are inconsistency in, they are missing data, they are format, there are times you have to also generate your own features. So with Python, using Python can help you to also go about it. And I believe one of the reasons it can also help is even if you have your data, right, and you want to assess, the performance, you don't necessarily have to, use, train and test play so that you divide your data into 80 and 20. No, you can use this synthetic data, right? Then just make sure that the features you are modeling is, similar to the features on your original data. And then you now what generate the data, do the model. Then we can now use you can just call the original data, predict it, and it is going to give you a results as the data you are also looking for. So it's not necessary that generating a synthetic data with Python is going to look so perfect. No, there is a way you can go about it, which I am going to walk us through from next week onwards. Yes, Mr. Gordon, is your question being answered?
Yeah, the part I wanted to get also clarification is the part of the biases. Will it have bias as regards our real situation in Nigeria, for example, or will it
Yes,
overcome that bias? Yeah.
yes, it can. It can do so. It can do so. So I think I'm trying to see, I think I generated a synthetic data here. Let me see if I can find it. And then, all right, I think I don't have it yet. So
I think we can go ahead. So that maybe since you have promised that you'll do that some other time.
Yes, I am trying to get how. Okay, I think I don't have that. We'll do that for Monday. All right. So let's move on. Okay. Yes, go ahead. Great, Akachi.
Sorry, sir. At a point, sorry, can you hear me, sir?
Yes, I can hear you.
Okay, at a point during the call, I couldn't hear you. So, I did not get the part where, or rather, how we decided upon regression instead of classification for the task that we are given. How do we decide to use regression instead of classification?
All right. So with the classification model, you want to know, you want to assess whether something is good or bad, something is true or false. You know, it assumes two values, right? So in this case, if I want to, I mean, um, if I want to generate this question, this business scenario into a classification problem, then my question is going to be that how do we assess the performance of a student and then know whether a student is going to drop out or not. So here we are looking at whether a student is going to stay in school or the student is not going to stay in school. So in here we are assuming whether staying in school is or staying is the student is not going to stay is not going to stay in school. So it assumes either a positive response or a negative response. So that is how classification problems are like. But with regression problems, you want to model what a specific what number. Let's say the exam score. We want to know the exam score of what the student. So the exam score of the student tells that our model is a regression model. All right. So that is the difference between classification and regression model. In the regression model, we are looking at what? A figure, a value. All right. You want to model what we are going to get. So at the end of the day, the student is going to get, 60. You want to know if the student is going to score 60 marks or you want to score mark 50. But with the classification, you want to know if the student is dropping out of the school or the student is staying in the school. So we can extend this business question by knowing that most of the case, if a student score maybe any mark lesser than 40%, that means that we know that student is not going to stay in the school. That student is going to drop out. So once we are done, we can also create another scenario for a regression task using the same context, where this time around we know if a student is staying in school or the student is not staying in school.
That is a follow-up on that. So, if the goal of, if our problem is to find whether or not a student will stay in school, like how likely they are to fail or how likely they are to drop out, and we have determined, say, 40% as the average below which the student is likely to fail or likely to drop out. Um, is it possible to use probably a logistic regression model with a threshold of 40% to determine likely to fail against likely to pass, or likely to drop out against likely to not likely to drop out?
Yes, that is right. In classification problems, we look at logistics and not linear modeling, right? So, but before that, you know, um, before you can assess whether a student is going to drop out of school or not, we are first going to assess the past students of dropouts and look at their score. Let's say in most cases, students who score less than 30 marks, all right, were almost dropping out. That means that our threshold is going to be that any student who score the mark below 30 is likely to drop out of school. So we are going to use the marks of the students and create another column, right? And then call on a Python code that tells us that if a student score a mark higher than 30, right, indicates pass, and if a student score a mark lower than 30, then indicates dropout, right? So that is how we are going to do that. Or we can say pass or fail. So if a student scored any mark higher than 30, for pass mark, we don't have pass mark in necessarily mean that a student is going to drop out. So with a dropout, we are just going to say if a student drop out, if a student score any mark higher than 30, the student stayed in school. And if the students, scored a mark lower than 30, the student drop out. So we can take a look into that, and then we have also another feature for it. And then now we can now use our logistic model to assess how our data is going to look like. I hope you get me now.
Sorry, sir, I mistakenly left the call at the last second. So, sir, please, so just I'm following. For this particular task, we are using linear regression. Then we are writing a Python script or code to classify those below a threshold, maybe 30 or 40, as failed, and then those above as passed or not likely to drop out. Is that what you're saying?
I'm saying that with that, we are not going to use regression. No. If we are assessing the performance of the students, right, who we are assessing whether the student is going to drop out or will not drop out, we are not going to use regression. We are not going to use linear regression. Sorry, rather we will take a look at logistic regression, and then we take it from there. All right.
Okay, sir. Thank you, sir.
You are welcome. Okay, any question again? All right.
Okay, so